Today we're going to talk about similar triangles and do a little introduction. Before we do that though, we are going to do a triangle review. We're going to find x in each triangle. So these lines on this triangle mean that these sides are congruent. And if we have those two congruent sides, then this angle, these two angles, are also congruent. So that one must be 74. Remember that the angles inside a triangle add up to 180, so you're going to use that to find x. Okay, so after you get your calculations by adding 74 together, you should get 148, and then 180 minus 48 equals 32. So you should have gotten 32 degrees. And then this next one we're actually going to skip. We haven't done that yet, and we'll get to that later this year. For this next part, we are dealing with an exterior angle, and we know that if we add these two angles together, that equals that exterior angle, or you should know that by now. So I can just do 122 minus 60 to get my answer. And you should get 62 degrees. All right, and we are also going to skip the last one because we have not done that topic yet either. Okay, so this symbol right here is the symbol for similar. And remember, similar means that they are the same shape, but not necessarily the same size. So similar polygons have these features. They have congruent corresponding. So congruent also means the same or equal. But similar polygons also have proportional sides. So we are going to kind of go back to where the transformations unit, when we were looking at similar figures, and to see which angles are congruent, we are going to match up corresponding angles and not sides this time. And we're going to do this, and we're going to fill in the missing angles. So if I look at my name of my triangle here, APF, just like before, the letters are going to be corresponding. So A is going to correspond to B. So if I look at this triangle here, A is 85 degrees. Well, that means in this triangle here, B is also going to be 85 degrees. And then my next one I'm going to look at is P. Well, P is going to correspond with Q. So if I'm going to look for P on my triangle, which is right here, and that's going to correspond with Q. So Q is also going to be 45 degrees. I'm sure you guessed, but for F, we're also going to look at how F is going to correspond with Z. And if F in this triangle is 50 degrees, that means it's going to be Z is going to be 50 degrees in that triangle. Okay, so for this next example over here, we have a triangle inside a triangle. And if you look at U, it's in both of them, and it's the same angle in each triangle. So each one is 60 degrees. So that is kind of unique, but then we do have to find out what this angle is over here by doing some calculations. We know that the three interior angles of a triangle add up to 180. So if I add 60 plus 90, I get 150. So 180 minus 150 means that E is 30 degrees. All right, so now I'm going to find the corresponding angle with E. So E is here, and also if I look at my triangle, in the same position on my triangle is P. So those are corresponding, so that means P is also 30 degrees. And I'm sure you guessed for O and W correspond. Well, O is 90 degrees, and then W is in the same position, and it's also 90 degrees. It might not always be the case, but because we have a triangle within a triangle, you're going to kind of pick the same position. Okay, so the next part is actually review, so I want you to fill this out on your own, and then you can check the answer key in Schoology, but finding scale factors should be a review. So you're going to complete this next part on your own. And then we'll go on to the back and do an examples on the back. Okay, so now what you're going to do is determine if these triangles are similar. So what we're going to do is we need to find this missing angle here. So if I add 80 plus 60, I get 140. And if I subtract 180 minus 140, I get 40 degrees. So this angle is 40 degrees. Well, if you look at it, we have matching angles here. So we have 80 degrees here, 80 degrees here, 60, 60, and then 40 and 40. So these triangles are similar. Okay, moving on to number 2. Looking at this example, both triangles have 73 and 39 as their angles. So what I'm going to do is I'm going to add 73 plus 39 because we want to find these missing angles here. So I get 112. And then I'm going to subtract that from 180 because the interior angles of a triangle add up to 180. So I get 68 degrees. So both of these are 68 degrees. And if you look, we have corresponding angles that are congruent. So yes, this is similar. So yes, these triangles are similar. And now, actually, I'm going to share with you a little trick. Since if you look at both of these angles we looked at, or triangles we looked at right away, we could find 2 sets of corresponding congruent angles. So in this first one, we had the 60 and the 80. And then in the second one, we had the 73 and 39. And I'm going to give you a little cheat because I know middle schoolers love to be lazy. You only need 2 sets of congruent angles to prove that the triangles are similar. So moving forward, you can just look at 2 sets of angles and make sure that they are congruent to prove that they're similar. All right, for this next part, we are going to use similar sides or proportional sides to prove that they're similar. So for this first one, I have a right triangle, or I'm going to assume it's a right triangle, but I'm looking at that angle right there to find my sides that are corresponding. So 12 is corresponding to 18, and I'm actually going to set up a proportion, which is triangle 1 over triangle 2, and I'm going to see if it is equal. And so here my next set of corresponding would be 10, and I'm looking at the bottom, which would be 10 to 15. So from here I'm going to cross multiply, and you might remember this from last year with the butterfly method. So if I multiply 18 times 10, I get 180. If I multiply 12 times 15, I also get 180. So yes, these are similar. Okay, for this next one, I have a triangle inside a triangle again. So triangle 1 is going to be this one here. So triangle 1 over triangle 2, which is going to be my bigger triangle. So 9 over triangle 2, which is 18. I'm going to see if it's equal to my other sides, which would be triangle 1 is 5, and I can't just use 5, but I have to use this whole thing, which is 10. And now I'm going to cross multiply to make sure that they are the same. So 9 times 10 is 90, and then 18 times 5 is also 90, so these are also similar. All right, what you can do is you can skip this part, and then for 7 and 8, try those on your own. You should be able to find those missing angles, especially if the statements say that these are similar. So use that in your knowledge of angles to try and find those missing angles, and then you can check the answer key on Schoology.